All right, so let's talk about SQL updates. Up to this point, we've been looking at how to retrieve data manually from the database, right? Using just plain out, select, using retrieve, what you can do is retrieve the fields, the records, and give predicates on how exactly you want the data from, right? But we also can do the reverse, right? Not only can we read, we also can write back to a database, right? So let's focus on some of those operations. So in SQL updates, we mean what we mean by updates. So anything that would change the state of the database, right? Where a read operation doesn't change the state of the database, whereas updates, of which there are three different variations. One is creating brand new data, right? That you're inserting new data into a database. The other one is either removing database records that were already there, right? And the last one is changing, making modifications of records that are already stored in the database, right? So those are the three update operations, and together, along with the select, which is kind of like the read operations, we say that those are the four basic operations of any data layer, right? Being able to create, read, update, and delete, right? It's oftentimes referred to as the CRUD operations, and we'll come back to that a little later and how to implement them from code. But let's take a look at some of the operations. Let's start with insert. Insert, like the name suggests, allows you to create a brand new data that you're going to add to a particular table. There's a couple of different syntax. Let's look at some of them. So the syntax reads insert into the name of the table that you want to insert the data into, and then values, right, which includes a parenthesized, comma-separated list of values. Okay. Or the alternative is that you additionally provide the columns where you're mapping the values to. Right? So here you would say that in column 1 I want to put value 1, column 2 I want to put value 2, column 3 I want to put value 3, and so on and so forth. Right? Now, if you don't provide the number of the column, the names of the columns here, it's optional. You can skip the name of the columns. What insert will do is that it will use the order in which the fields were declared. Right? When you declare it first in the create statement, right, that order, right, it'll assume that that's the order in which you want to add these values in there. Okay? The values don't all have to be there, but they have to be in the order in which the fields were declared. The problem with some of these is that perhaps some of these fields you want to skip over them, right? You don't want to provide the values that they're nullable values, right? But here you can't. Right? You can't skip them. You have to go in the order that they were declared. You can leave off some values of fields afterwards, right? If they're nullable, you can maybe provide just the first 2 or first 3 values and just ignore the 4th, 5th, and 6th if those values are optional. But they have to be done in the order that they were declared originally. Here's a quick example. We have a table that already has 3 records, and we are inserting a brand new one with the ID 4, for a last name Boone, first name Daniel, and address 2 Mill Lane, Draken. Okay, and we'll see that it's being added to the table. Here I'm displaying it as the last record, and indeed typically it will be added chronologically like this. But again, don't assume any particular order. Here's another one, inserting into persons, but here we're specifying the fields, right? The person ID, the last name and first name, and then the values. Notice we're skipping over the last 2 that presumably are nullable and are not required. Okay. This one is also convenient if you have like an auto increment and you can skip over the ID, right? You won't have to provide it. right? Or and the database would set the auto increment for you. Here's a here's an example of inserting a brand new student record. The student ID, the name, the major ID, and the graduation year. And here are the values: 10, Ron, 30, and 2009. Right, not all values need to be specified. If you don't specify them, it will use the default value for that particular record. All right, so let's look at some other ways that you can insert into a database. Right, the ways we've done it right now is inserting one record at a time, but certainly you can insert them based on other queries, right? Queries that might join multiple tables, right, and create a brand new table based on a set of source tables, right? So here's an example of using a select statement that would provide the data for an insert, right? So here's a select that is joining two tables, table 1 and table 2, right? Grabbing records and fields and values from those two tables, identifying those records, and then extracting 3 fields from them, the first, second, and third column, 2 from column from table 1, and another one from table 2. Right? Now we have to make sure that the data types of those columns match the data types of the columns that we're inserting. And certainly we need to make sure that the data types match. Right? And ideally this would be this could be a view that you can run from time to time if you want to update something that you want to drop into the table and just recreate it and reinsert it into a database. Here we are at here's another example that we're using the alumni table to calculate who of those folks that have already graduated that are beyond the graduation year, which ones are alumni. So presumably it's a subset of the original set of students. So here's a brand new table called alumni that has fields: student ID, student name, major, and the graduation year. Right, and we can populate this from an existing students and department table. We can combine those two and join them. We can join the student table and the department table where the student's major ID matches the department's department ID, right? And but we only want those records where the year, right? If we take a look at the current date, we look at the current year, right? We can extract the year out of that and compare it with the student's graduation year, right? So if it's less than, if they graduated in the past from today, then we're going to consider them as alumni, right? And then we extract some fields from either one, from the some fields from the student, some fields from the department table, a couple, 3 fields from the student table, 1 field from the department table. And we're building the records that we're going to insert into the alumni table that presumably match data types, right? So student ID, we're grabbing from student ID, student name, department name, and the graduation year, right? Mix and match. Okay, make sense? Here's another one. Inserting a new student with the same major and graduation year as student number 1. Here's where inserting. What are we doing here? Okay, so it looks like we're copying from an existing student, from the first student. We're copying it into a brand new student, but we are overriding the name of the student. Right? This, perhaps we're giving it a brand new student ID. We're giving it a brand new name, but we are copying the major and we're copying the graduation year. So this is kind of like a copy and override a couple of fields, right, from an existing record. Deleting. So deleting. So we looked at the insert. Let's look at delete and update. So delete, as the name suggests, allows you to remove records that were already there. It has a couple of different syntheses. Let's take a look at them. You can either say delete star or just delete from without the star from the table name. Now, unfortunately, if you don't provide a where clause, right, it will be interpreted as you want to remove all the records, right? They all match. Although newer versions of databases will have a configuration that will save you from this and say that it won't run any query that doesn't have a specific where clause, just to avoid things like this happening, right? So presumably you would not want to remove all the records. Instead, you want to identify a certain set of records that you do want to remove, and for that, you can use the where clause, right, as a predicate that would identify the subset of the records that you indeed want to remove. And so where some column is equal to some value. So here's an example that we want to remove the last one, where the last name and first name match Norton Edward, and then it's gone from the resulting set of tables. Here's another example where we are calculating the deletion from a subset, from a subquery. So in this subquery, we want to identify all the we want to delete all the sections that have no enrollments, right? So there might be that we open all these sections, but nobody enrolled in them. We want to identify them, and so we might want to find first all the sections that do have an enrollment. And once we have all the section IDs, this will be a list of IDs, right? And then we can use that in the not in operator, right? So that we can say, okay, well, retrieve for me, from the section table, find me all the records whose section IDs are not in the enrollment table. So there were no entries in the enrollment table for a particular section, so we want to remove it. So we had opened up that section, and now we are deleting it. And these predicates can be, as complex as you want them, right? To match exactly what records you want to remove. All right, so we'll look at insert. We looked at delete. Let's take a look at update. Okay. So update, as the name suggests, is to be able to change data from a table that already exists, records that are already there, and we just want to tweak it, perhaps change a couple of the fields of some of the values and some of the fields in a particular record, and so the syntax reads as update, the name of the table, then a set operator where we set specify the columns and the new values for those columns. Again, we would use a where clause. If you don't have the where clause, by default, it would mean that you want to have all the records have exactly the same values across for the whole table, and that's typically not what you mean. Often, most commonly, you would use a where clause to identify exactly which records you want to update. And again, this where clause can be as sophisticated as you want. So here's an example. We have a Norton Edward, a record that we want to update. And we're using the where clause to identify that specific record, and we want to set an address that wasn't there before. We want to update it to be 45 Groton Road, Lowell, and so we updated the value to be, it used to be null, and now it's Groton and Lowell. Here's one where we forgot to put the where clause. Right? And so it's just going to go through, and all the records get the same value. Again, newer versions of databases will guard against this. If you don't have a where clause, it won't typically let you go through. Here's another one. One of the cool things is that you can use previous values of a field, right, to update the new value of records, which is non-trivial. For instance, not all databases support this. For instance, MongoDB doesn't support it. As it identifies the records, you can't use the old values of the original record to update the values of the new record. Right? Unfortunately, you would have to do it programmatically. Right? So this is saying update the new value of the graduation year to be equal to the original graduation year plus 1. This is perhaps students that maybe are changing majors or like my daughter did. She changed majors, so she's going to graduate 1 year later than she was supposed to graduate. More money. All right, so that was updates.